Hello there, intermediate algebra students. Time for our last lesson in this first little mini unit of ours. This one we're looking at lessons 2.5, 2.6, and 2.7, rational number operations. Now, a lot of times when you hear that word operation, you might think of this type of operation. It doesn't look too pleasant at this point. But when we talk about math operations, we're talking about adding, subtracting, multiplying, dividing. So those are things that you're used to doing. That's what we mean by an operation. So we're going to go on to the next now and examine these a little bit in more detail. Now, when we talk about a rational number, that's any number that can be written as a fraction. So from now on, when you hear that word rational, in math class anyway, we're always talking about a fractional type number. Okay? Taking a look at these, a fraction may not always right away appear to be a fraction. Which of the following here do you think are rational numbers? Well, certainly one like the first one, -2/7, that one is a rational number for sure because it's a fraction. It's okay if it's negative. 37.2, what about that? Well, that may not look like a fraction right at the moment, but can I write it as a fraction? The answer is yes. If I write this as the fraction 372 over 100, then that fits the bill. So not usual method of looking at rational numbers, but it is considered rational. Pi, that's a number you know from mathematics. That is actually not a rational number. You cannot exactly equal the number pi by writing it as a fraction. How about this one, 0.4 repeating? Doesn't look like a fraction, but we know, and you can check this on your calculator, that anytime you have a bar over a number like that, that's what we can write that much over either 1 9 or 2 9s or 3 9s, depending how many digits are repeated. So if it's 0.4 repeating, that is actually equal to the fraction 4/9, so that means it is a rational number. 5 1/8, that's a mixed number, but you might recall how to change this to an improper fraction. Take 5 times 8, which is 40. Then I add 1, so I get 41 in the numerator here. And my denominator stays as 8. So that is equivalent to 41/8. Once again, that is a rational number. How about 0? Can I write 0 as a fraction? Sure. In fact, if I write 0 over any number, it's going to equal 0. So 0 is also considered to be a rational number. Just remember that rational numbers are fractions. Now, first operation we're going to look at here is adding and subtracting rationals. And from your past studies, you probably remember that when you add fractions, you must have a common denominator. That's huge. That bottom number, called the denominator, must be the same. And sometimes you'll see maybe a couple of the first problems on your assignment that we work on tomorrow, can't remember how to spell denominator, will have common denominators, but most of the time they don't. So let's just review how to do that. First problem here, 3/4 plus 1/8, not a common denominator. We have a 4 and an 8. So I want to make an equivalent fraction that would have that same denominator. So I recognize on my first fraction, if I multiplied that by 2 over 2, I would have a common denominator of 8. Now, why do I use 2 over 2? Well, 2 over 2 is the same as the number 1. When I multiply something by 1, it does not change its value. So that's why I do that. It gives me an equivalent fraction that will have a common denominator. My numerator then will be 6. 2 times 3 is 6. So then I can add the 1/8 to it. Now my denominators, sure enough, they are the same. And so I can just add the 6 plus 1 and I get 7. Remember, you do not add the denominators. That stays the same. So 3/4 plus 1/8 is 7/8. Next one, a little trickier here. Not only is it not common denominators, but all kinds of goofy signs. Now you may remember that when you subtract a negative, that's like adding a positive. So I'm just going to think of this as -5/9 plus 2/7. I'm going to write that over here right away. That might simplify things a bit, I think. Now, certainly not a common denominator here. One thing you can always do is just multiply by the other denominator. That looks like it might be our best bet in this case. So for instance, I am going to multiply the first fraction by 7 over 7, because 9 times 7 then will be a common denominator. My second one I'm going to multiply by 9 over 9. Just like in the first example, I'm multiplying by a number over itself, which is equivalent to 1. All right, let's see what I get here. I'm going to switch colors here again. Don't worry about the negative signs yet. So 7 times 5 is 35 over 63. And 2 times 9 is 18 over 63. This is a plus sign. This is a minus sign. And I do have common denominators here. You have to worry about your negative signs. What is negative 35 plus 18? Looks like that's going to be negative 17 over 63. So, common denominators, key additional things. Now, what about when you multiply? When you multiply rationals, it's actually, most people think it's a bit easier because you do not have to have common denominators. And when you multiply rational numbers, you just multiply across. So a cross in the numerator and a cross in the denominator. So for instance, on the first one, 2 times 1 is 2. 3 times 8 is 24. My answer is 2/24, so I can reduce that to 1/12. And then I notice since I have one negative sign there, it should be negative. Now, what you may have also learned how to do in your mathematical career is something called canceling or reducing. On what I just did here, I reduced at the very end after I had multiplied, but you might want to reduce earlier. For instance, I might notice that 2 goes into 8. And in fact, if I divide this by 2, I get 1. If I divide this by 2, I get 4. Now when I multiply across, I get 1. 1 times 1 is 1. On the bottom, 3 times 4 is 12. There's one negative sign, so my answer is negative 1/12. That's the same answer I got the other way I did it, but a lot of times people like to do the reducing beforehand. Works out kind of good. All right, let's try our other example here. This one's slightly trickier because we have that mixed number. So this is going to be 5/7. This is 2 times 8 is 16, and 5 is 21/8. This one is negative and this one's negative. Any canceling or reducing that you see you can do here? Yeah, 7 and 21. 7 goes into 21 3 times. That's the best I can do there. And so my final answer, 5 times 3 is 15. 1 times 8 is 8. Two negative signs. When you multiply two negatives, you get a positive. So your answer could be 15/8 or 1 7/8. All right, now what about dividing rationals? Well, dividing is kind of tricky, although as you can see by this little quote, is easy as pie. Dividing fractions is easy as pie, just flip the second and multiply. It's supposed to rhyme kind of, I guess. And if you remember that, that is the process we use when we multiply fractions, or excuse me, divide fractions. So for instance, my first one here, remember the first fraction stays the same all the time. So that's going to stay as negative 2/5 times, now here's where I'm going to do the flipping. Remember the fancy mathematical name for that is the reciprocal. And so here it is. Do you see anything that I can reduce here? I think I see a little bit. I see that 5 will go into 10 2 times. And so now when I multiply this out, 2 times 2 is 4. 1 times 3 is 3. My answer is 4/3. I have two negatives, so I know it'll be positive 4/3, and that's my answer. All right, what about the second one here? Again, I keep the original fraction the way it is. That's 5/6. This time I'm going to multiply. Now, what's the reciprocal of negative 3? It's actually going to be negative 1/3. And I can't really do any reducing here. Looks like my final answer is going to be 5/18 with a negative sign in front. So dividing fractions, multiply by that reciprocal, or the flip of the second. Here's a couple more weird ones that we use when we divide here. Notice the first one, that really should say -6 divided by 3/2. So I could write it like this. It's equivalent to saying this, -6 divided by 3/2. And of course I'm going to change that then to -6 times the reciprocal, which is 2/3. Remember, if you have a whole number, you can write that as over 1. See any reducing you can do here? Yeah. 3, if I divide by 3 there and I divide by 3 there, I get that. And now my final answer I see is going to be 2 times 2, which is 4. My denominator is just 1. And I only have one negative sign, so my final answer there is going to be just -4. Second one over here. This one is kind of strange because it looks kind of fractiony. And the idea here is that this denominator is the denominator for both parts here. So the strategy for these kind of division problems is to split it up into 2 parts and write your denominator under each one. And then if you're lucky, you might be able to do some reducing on each one of these parts. And so sure enough, it looks like I can take 8 divided by 2, or 2 goes into 8 4 times there, so I end up with just 4x. And here 30 divided by 2 is 15, so my final answer then becomes 4x minus 15. One more example we'd like to look at. Here's another case where we would use rational numbers to do a fairly common type of exercise. You'll do this in science for sure. Missy Franklin, who you probably watched in the Olympics this past summer, won the Olympic 100-meter backstroke in about 58 seconds. How many miles per hour was she actually swimming? Well, the way we like to approach this is sometimes called unit analysis. I'll kind of write this out how this works. She could swim 100 meters in 58 seconds. Now, we'd like to get this down to miles per hour. So I'm just going to multiply by equivalent things. I know that 1 mile is equal to 1,600 meters. And if we have some track people in the audience here, you know that. And the advantage here is that now my meters will be able to cancel out. If I have a unit on the numerator and the denominator, they will cancel out. Remember, I'd ultimately like to get to miles per hour are the only 2 units I want left. Then I have 60 seconds in 1 minute. Now, the reason I need that is because I want to cancel out ultimately these seconds here. Okay? And then I'm going to lastly multiply by 60 minutes in 1 hour. So as you can see, what's going to happen here, as far as the units, the seconds here will cancel out. The meters will cancel out. The minutes will cancel out here. So my units that I have left are miles per hour, which is what I want. Now, I did this in my calculator. We'll kind of go over how to do that in class. But what's going to happen here is basically on your calculator, you can take 100 times 60 times 60. That's going to be in your numerator. And the bottom then I'm going to divide by 58 times 1,600. We'll show you how to do this in your graphing calculator. And the answer I came up with was about 3.88 miles per hour. Doesn't sound real fast, but for a swimmer, that's pretty darn good. All right, good job, everybody. Sorry, this is kind of a lengthy lesson to watch, but we'll be working on this in class, and you'll be familiar with a lot of this. Bye now.